Electrical machinery 1. DC generator armature reaction. Armature reaction statement. Armature reaction is mean the effect of magnetic field set up by armature current on the distribution of flux under main poles of a generator. Two effects: demagnetizes or weakens the main flux. Second, cross magnetizes or dissociates. Demagnetizing hinge poles 2, that is bipolar flux distribution of a bipolar generator. Where there is no current in the armature conductors. For convenience, only two poles have been considered. The brushes are shown touching the armature conductors directly, although in practice, the touch commutator segments. The flux is distributed symmetrically with respect to the polar axis, which is the line joining the center of N and S poles. The magnetic neutral axis or plane M and A coincides with the neutral axis or plane. Magnetic neutral axis may be defined as the axis along with no EMF is produced in the armature conductors because they move parallel to the lines of flux, or M and A is which is perpendicular to the flux passing through the armature. Load is connected between the brushes. Cross magnetizing. Conductors carry current in such a direction as to produce combined flux pointing vertically downwards, right angles to the main flux. This results in distortion of the main field. Hence, these conductors are known as cross magnetizing conductors or constitute distorting ampere conductors. Applying Fleming's right hand rule, figure 1, current is coming into the conductor and out of the conductor. Downward finger shows direction of magnitude, small finger shows Fleming's right hand rule into the pole, that is clockwise directions. In this diagram, crosses are downward directions, circle in crosses, circle in dots mention upward flow, that is flux upward flow. Theta is brushes move shifted angle. Conductor shifted angle is 2 theta. Armature reaction. Armature reaction is mean the effect of magnetic field set up by armature current on the distribution of flux under main poles of a generator. The armature magnetic field has two effects. It demagnetizes or weakens the main flux, and it cross magnetizes or dissociates. Armature reaction. From the figure, it is clear that the magnetic flux distribution inside the machine is disturbed. The proper position for locating the brushes is the line representing the magnetic neutral axis M and E. First figure, if the brushes horizontal, brushes are correctly placed. Magnetic neutral axis is the line drawn perpendicular to the direction of magnetic field. The diagram shown M and A is perpendicular to resultant flux, that is armature flux. Under load condition, the magnetic neutral axis M and A is horizontal, but under load condition, M and A is shifted from horizontal axis. Resultant flux horizontal to M and A. F2 is flux due to armature. Shifted theta angle. Conductor shifted to theta. Let theta be the angle of this shift. In order to achieve proper commutation, the brushes must always kept along M and A. This means that when machine is loaded, the brushes must be shifted by angle theta so that the brushes will lie on M and A. Corresponding to loaded conditions, commutator converts AC to DC. Consider the armature conductors which lie within the angle 2 theta on the left side and also on the right side. All the conductors above the M and A carry current same direction into the pole. Below the M and A conductors same direction out of the pole. From the figure, it is clear that the conductors which are enclosed within in the angle 2 theta from the left side and also on the right side will together produce magnetic field which is vertically upwards. This is called magnetization reaction of armature reaction. Armature reaction, DC generator. Let IA be the armature current, Z be the total number of conductors in the armature. IA divided by capital A is equal to current in each conductor. So armature current in each parallel path. Demagnetization is equal to Z into IA divided by A into 4 theta divided by 360 into 1 divided by P. P representation number of poles. We are using bipolar generators, so P value is 2. Ampere turns per pole demagnetizes Demagnetization of the armature conductor per pole is equal to Z into Ia divided by A into 4 theta divided by 360 degree into 1 by P. Ampere turns per pole demagnetization, that is ATD divided by pole is equal to Z Ia divided by A theta 180 into 1 divided by P. Demagnetization, that is small d, mentioned. A is number of parallel paths. Similarly, the remaining conductors in the upper side and the lower side of armature in the above figure will together produce magnetic field in horizontal direction from right to left. This is called demagnetizing effect of armature reaction. This can also be expressed with the help of main formula as follows. Previous formula as follows. Cross magnetizing ampere turns per pole, that is ATC per pole. C is cross magnetizing. ATC divided by pole is equal to total ampere turns per pole minus demagnetizing ampere turns per pole. ATC per pole, finally we find equation is equal to capital SZ bracket of Ia divided by A bracket and open bracket 1 divided by P close bracket and open bracket 1 divided by 2 minus theta divided by 180 degree close bracket. Cross magnetizing effect of armature reaction will make the flux distribution inside the machine non-uniform, that is shown in figure. Leading edge, that is weakened, trailing edge is strengthened by air gap. 2 theta is conductor shifted degree, theta is pressure shifted degree. From the figure it is clear that the magnetic field in the air gap, it is become weakened from the leading edge of the pole and become strengthened at the trailing edge of the pole. Conductors carry current as such a direction as to produce a combined flux printing vertically downwards at right angles to the main flux. This results in distortion of the main field. Hence, these conductors are known as cross magnetizing conductors and constitute distorting ampere conductors. Our question and answer. Armature reaction hint for. Armature reaction DC generator. 2 mass hint. Load is connected between brushes. Current direction found out from applying Fleming's right hand rule. Fleming's right hand rule shown in figure, that is direction of motion. Downward finger is direction of magnitude. Small finger is into the pole, that is clockwise direction. Upward flow represents dots. Downward flow represents crosses. 2 flow, upward flow and downward flow. Armature reaction set up by armature current on the distribution of flux under the main poles of a generator. 2 effects, that is 2 poles generator using demagnetize and cross magnetize. Demagnetize effect poles is equal to 2, that is bipolar generator. MNA is magnetic neutral axis. Brushes must always kept along MNA. Commutator converts AC to DC. Shift angle theta. Load condition, brushes shifted by angle theta. Brushes will lie on MNA. Loaded conditions. Conductors 2 theta move from the left side and also on right side, vertically upwards. Armature reaction. Cross magnetizing effect. Vertically downwards conductor combined flux, non-uniform. The source is weakens, leading edge of pole, strengthen, trailing edge of pole. Armature reaction. Ia divided by A, current in each conductor, armature current in each parallel path. Demagnetization. Z and Ia divided by A into 4 theta divided by 360 into 1 divided by P. P is number of poles, that is 2. Demagnetization. Ampere turns per pole, ATD divided by pole is equal to Z Ia divided by A theta divided by 180 into 1 by P. Demagnetize. ATC divided by pole, cross magnetization. Z into Ia divided by A into 1 divided by P into 1 divided by 2 minus theta divided by 180 degree. Field current needed for neutralizing the magnetizing effect of armature reaction. Number of turns in the X is equal to ATD divided by pole, where X is field current in ampere. That is field current find out formula. ATD is demagnetized ampere turns per pole. DC generator problem. The 4-pole wave-wound generator armature has 880 conductor. It delivers 120 amperes. The brushes have been shifted through 3 angle degrees from the geometrical neutral axis. The number of poles in the machine is 4. Calculate the demagnetizing ampere turns per pole. Calculate the cross magnetization ampere turns per pole. The additional field current which is needed for neutralizing the demagnetizing effect of armature reaction. The number of turns per main pole 1100. Given values Z880, IA 120, P4 angular theta is 3. We are always known in theoretical classes wave binding number of parallel paths A is equal to 2. ATT divided by 4 is equal to ZIA divided by A into theta 180 into 1 divided by P. Demagnetization ampere turns pole formula. 880 into 120 divided by 2 into 3 divided by 180 into 1 by 4. Put required values we after ATT divided by pole is equal to 220. ATC divided by pole formula is ZIA divided by A into 1 divided by P into 1 divided by 2 minus theta divided by 180. Put required values we obtain ATC divided by pole 6380. That is cross magnetization per pole. C part, find field current. Number of turns into X is equal to 220. That is number of turns 1100 given value into X is equal to 220 is ATT divided by pole. X is equal to 220 divided by 1100. X is equal to 0.2 ampere. Find out value gives 220 is ampere. ATT divided by pole. Thank you.